Today, we're diving into the fascinating world of convection currents, a key process driving the movement of tectonic plates and causing continental drift. I'll break it down into simple steps to help you understand how these powerful forces shape our planet. Step 1 is heat from the Earth's core. The journey begins deep within the Earth. The core generates heat through radioactive decay and residual heat from the planet's formation. This heat rises towards the mantle, the layer above the core. Step 2 is then mantle convection. As the heat rises, it creates convection currents in the semi-solid mantle. These currents are similar to the way water moves when heated in a pot. The hot mantle material rises towards the Earth's crust, while the cooler material sinks back down. Step 3 is movement of tectonic plates. The convection currents in the mantle create drag on the overlying tectonic plates, causing them to move. These plates can move away from each other, divergent, move towards each other, convergent, or slide past each other, transform. Step 4 is continental drift. This movement of tectonic plates leads to continental drift. Over millions of years, continents have shifted from one massive landmass, called Pangaea, to their current positions. This process continues today, slowly but continuously reshaping the Earth's surface. Step 5 is geological activity. The movement of tectonic plates due to convection currents also results in geological activities such as earthquakes, volcanic eruptions, and the formation of mountain ranges. These activities are most prominent at the boundaries of tectonic plates. Next time you learn about earthquakes, volcanoes, or shifting continents, remember the role of convection currents in the mantle. These powerful forces drive the movement of tectonic plates and continuously reshape our planet. We're going to explore where earthquakes and volcanoes occur around the world and what explains their global pattern. Let's break it down into some easy to follow steps. The Earth's crust is divided into large slabs called tectonic plates, which move slowly due to convection currents in the mantle below. Where these plates meet, known as plate boundaries, enormous forces are released, and that's where most earthquakes and volcanoes occur. Constructive or divergent plate boundaries, where the plates are moving apart, allowing magma to rise and form new crust, like along the mid-Atlantic ridge between Eurasian and North American plates. Or we have the destructive or convergent plate boundary, where plates move towards each other and one is forced beneath the other in a process called subduction, forming volcanoes and powerful earthquakes, such as along the Nazca and South American plates. Or finally, conservative or transform plates, where plates slide past each other, causing friction and sudden jolts of energy that create earthquakes but no volcanoes, like along the San Andreas Fault in California. If we zoom out and look at a world map, we can see a huge belt of volcanoes and earthquakes circling the edge of the Pacific Ocean. This is known as the Pacific Ring of Fire. This region includes countries such as Japan, Indonesia, the Philippines, New Zealand, and parts of the west coast of the Americas. It is the most seismically active region on Earth, with around 75% of the world's active volcanoes and about 90% of global earthquakes occurring here. That is because the Pacific Plate is surrounded by many other plates. It is being subducted beneath some plates and colliding or sliding past others. These complex plate movements make it a natural hotspot for tectonic activity and hazards. Not all volcanoes fit neatly along plate boundaries, though. Some occur in the middle of tectonic plates, far, far away from any boundaries. These are often called hotspots. Hotspots can happen when a plume of very hot magma rises from deep within the mantle, melting through the crust to form volcanoes. The Hawaiian Islands are the best known example. They sit right in the center of the Pacific Plate. As the plate slowly moves over the stationary hotspot, new volcanoes form in a chain. This is why Hawaii's volcanoes get progressively older as you move away from the current one known as Kilauea. So while volcanic activity mostly occurs along boundaries, hotspots remind us that the Earth's mantle can create volcanoes anywhere, even in the middle of a plate. Tectonic activity is still shaping our planet today, and one of the most exciting examples is the East African Rift Valley. Here, the African plate is slowly splitting into two smaller plates, the Nubian plate to the west and the Somali plate to the east. As these plates pull apart, the land between them is sinking, creating long rift valleys, volcanoes, and frequent earthquakes. Over millions of years, this process could form a new ocean as the rift continues to widen. A modern day example of how continents break apart. The East African Rift shows that tectonic activity and hazard zones are not fixed. They evolve, and new boundaries can form as the Earth's plates keep moving. So, to sum up, most of the world's earthquakes and volcanoes occur along plate boundaries, where huge forces are released as plates collide, separate, or slide past each other. The Pacific Ring of Fire is the most active zone, and in the East African Rift Valley, we are witnessing the early stages of a new plate boundary, a small glimpse into the future of Earth's ever-changing surface. Today, we're going to explore the fascinating process behind the formation of transform plate boundaries, where some of the Earth's most significant seismic activity occurs. It may seem complex, but I'll break it down into some easy to follow steps. Step 1 is lateral movement of plates. Transform plate boundaries occur where two plates slide past each other horizontally due to convection currents. Unlike collision or divergent boundaries, the plates at a transform boundary move sideways relative to each other. Step 2 is the shearing forces. The movement of the plates creates shearing forces. These forces can cause friction to build up along the boundary where the plates are in contact. Step 3 are earthquakes. The stress from the shearing forces continues to build up until it is suddenly released as seismic energy, causing earthquakes. These earthquakes can be very powerful and destructive because they occur near the Earth's surface. Next time you hear about an earthquake, remember the dynamic and powerful forces at work beneath the Earth's surface and at transform plate boundaries. Today, we're diving into the fascinating world of constructive plate boundaries, also known as divergent plate boundaries. We'll break down this process into simple steps so you can easily understand how new crust is formed and how it shapes our planet. Step 1. What are constructive plate boundaries? Constructive plate boundaries occur where two tectonic plates move apart from each other due to convection currents. This movement creates a gap between the plates. Step 2 is the formation of mid-ocean ridges. As the plates separate, magma rises from the mantle to fill the gap. When this magma reaches the ocean floor, it cools and solidifies, forming new crust. This process creates underwater mountain ranges known as mid-ocean ridges. The Mid-Atlantic Ridge is a prime example. Step 3 is creation of rift valleys. On land, when tectonic plates diverge, they create rift valleys. These are large depressions formed by the sinking of the Earth's crust. The East African Rift is a significant example where continental plates are being pulled apart. Step 4 is volcanic activity. The rising magma at constructive boundaries not only forms new crust, but also creates volcanoes. These volcanoes are usually less explosive than those at destructive plate boundaries because the magma at these boundaries are less viscous. Iceland, located on the Mid-Atlantic Ridge, has many volcanoes. Step 5 is sea floor spreading. As new crust forms at mid-ocean ridges, it slowly moves away from the ridge, causing the seafloor to spread. This process continually adds new material to the ocean floor, pushing older crust further away from the ridge and contributing to the expansion of ocean basins. Next time you think about the Earth's crust, remember the dynamic process of the seafloor spreading and volcanic activity at constructive plate boundaries. These boundaries are vital in continuously shaping and reshaping the Earth's surface. Today, we're diving into one of the most dramatic geological events on Earth, destructive plate boundaries. These are the boundaries where volcanoes erupt and mountains rise, but also where some of the world's deadliest earthquakes strike. A destructive plate boundary, also called a convergent plate boundary or a subduction zone, is where two tectonic plates meet and move towards each other. Usually, it is a dense oceanic plate colliding with a less dense continental plate. Because the oceanic crust is denser, it gets forced down underneath the continental plate. These plates move because of convection currents in the mantle. Heat from the Earth's core causes the hot magma to rise, spread out, and drag the tectonic plates with it. This slow movement drives plates into each other over millions of years. As the oceanic plate sinks, it forms a deep ocean trench at the point of subduction. This trench marks where the crust is being pulled down into the mantle and being destroyed by the heat and the pressure. A famous example of this would be the Peru-Chile Trench along the west coast of South America. As the subducting plate melts, it forms magma, which is less dense than the surrounding rock. This magma rises through the continental crust to the surface, forming a volcano. This is how we get explosive volcanic eruptions. This magma is thick and full of gas from the melting plate, making eruptions both violent and dangerous. These plates don't slide smoothly. They often get stuck, causing pressure to build up. When the pressure is suddenly released, it causes earthquakes. Also, as the continental plate is pushed and crumpled, it can form fold mountains, just like the Andes in South America. Today, we're exploring the incredible phenomenon of volcano formation at hotspots. We'll break this down into some easy steps so you can easily understand how these fiery mountains emerge from the depths of the Earth. Step 1: Heat from the Earth's core. It all starts deep within the Earth, where intense heat from the core causes the mantle to become very hot, causing thermal plumes that rise towards the surface. Step 2: As the heat rises, it forms mantle plumes, columns of extremely hot rock that ascend through the mantle. Step 3 is in the melting of the crust. When the mantle plume reaches the base of the crust, the intense heat causes partial melting of the overlying rock. This melted rock, or magma, begins to accumulate in the magma chambers beneath the Earth's crust. Step 4: Formation of volcanoes. As the pressure builds up in the magma chamber, magma forces its way through cracks in the Earth's crust. When it reaches the surface, it erupts, forming a volcano. These eruptions can occur repeatedly, building up layers of lava and ash to form large volcanic structures. Step 5: Island chains and plate movement. Over millions of years, as a tectonic plate moves over the stationary hotspot, a chain of volcanoes can form. Each new volcano forms as the plate moves away from the hotspot, creating a sequence of volcanic islands, like the Hawaiian Islands. Next time you see a volcano, remember the incredible journey of heat and magma from deep within the Earth to the surface. Hotspots are a fascinating part of our planet's geology, continually shaping and reshaping the landscape.